Now that we have a good foundation of the parts of a triangle and different parts within a triangle, we're going to talk about inequality among triangles. So let's go over the definition of inequality. If you remember from algebra, inequality was represented with greater than, less than, greater than or equal to, or less than or equal to. And if we're going ahead and comparing numbers, we could also say that numbers could be equal or not equal. So for inequality, think about it as comparing a value. We either have something that's greater than another value, less than another value, or those two values are equal to each other. And in order for a value to be greater than another, so for any real numbers a and b, a is greater than b if and only if there is a positive number c such that a equals b plus c. So we're going to start out, since this is an if and only if, it can be read in two ways. For any real numbers, if a is greater than b, then there is a positive number c such that a equals b plus c. So we're saying that a is greater than b first. That's what we know. And we know that 5 is greater than 4. So let's say that a is equal to 5 and b is equal to 4. Then there is a positive number c such that a equals b plus c. So if we have a equals b plus c, a is 5, b is 4, figuring out the value of our c, we're just going to take away 4 from each side and get that 1 is equal to c. So 4 plus 1 equals 5. And that c was a positive number. Now let's work in the other direction. The other direction says that if there is a positive number c such that a equals b plus c, then a is greater than b. So let's start with our equation, a equals b plus c. So I'm just going to fill in numbers that make this equation true. If a is 10, b can be 6, and 6 plus 4 will get us to 10. So our a is equal to 10, our b is equal to 6, and our c is equal to 4, and 4 is a positive number. So is a greater than b? Yes, because 10 is greater than 6. Now that we have a good foundation for inequality, let's go over the properties of inequality for real numbers. So as far as properties of inequality for real numbers go, our first property is the comparison property. So for all numbers a, b, and c, a is less than b, a is equal to b, or a is greater than b. There are no other possibilities. One number is less than another number, the two numbers are equal, or the number is greater than the other number. Our next property is the transitive property. The transitive property says, for all numbers a, b, and c, if a is less than b and b is less than c, then a is less than c. If a is greater than b and b is greater than c, then a is greater than c. Let's look at the first one. If we have a is less than b, so 1 is less than 3. So this is my a is less than b. And we have b is less than c. So we know that that b is 3, and it's got to be less than some number c. So b is going to be less than, let's say, 6. Then a is less than c. So our a was 1, which is less than c, which was 6. So a is less than c. And you can do the same thing for the second part. Now let's look at the addition and subtraction property. So the addition and subtraction property says that if A is less than B, then addition, A plus C is less than B plus C, and for subtraction, A minus C is less than B minus C. Again, if A is greater than B, then for addition, A plus C is greater than B plus C, and A minus C is greater than B minus C for subtraction. If we were to plug numbers in, again we can use 1 and 3. 1 is less than 3, and let's use C as any number. Let's say that C is 5. Then 1 plus 5 is less than 3 plus 5, because 6 is less than 8. And 1 minus 5 would be negative 4, and negative 4 is less than 3 minus 5, which would be negative 2. Now let's go over the multiplication and division properties. So for our first one, we have, for all numbers A, B, and C, if C is greater than 0 and A is less than B, then A times C is less than B times C. That's a multiplication property. And A divided by C is less than B divided by C. That's the division property. Now let's look at it if C is greater than 0 and A is greater than B. So if C is greater than 0 and A is greater than B, then A times C is greater than B times C, and A divided by C is greater than B divided by C. If C is less than 0, meaning that C is a negative number and A is less than B, then A times C is actually greater than B times C, and A divided by C is greater than B divided by C. And that's if C is a negative number. So think about this. If we had A that was less than B, so we had 3, which is less than 4. And our C is some negative number, let's say negative 1, because negative 1 is less than 0. Then 3 times negative 1 is greater than 4 times negative 1. That would be negative 3 is greater than negative 4. Looking at a number line, we know that to be true. Here is negative 3, and negative 4 is less than negative 3. So negative 3 is greater than negative 4. And if we did division as well, 3 divided by negative 1 is greater than 4 divided by negative 1. Then we'll have negative 3 is greater than negative 4, which we just showed on the number line. Let's look at one more case. Our last and final case is if C is less than 0 and A is greater than B. Then A times C is less than B times C, and A divided by C is less than B divided by C. So those are the properties of inequality for real numbers. We have the comparison property, the transitive property, addition property, subtraction property, multiplication property, and division property. And just as we had properties of equality for real numbers, segments, and angles, we'll also have properties of inequality not just for real numbers, but those same inequality properties also apply to segments and angles. So now let's apply inequality properties among angles into our next theorem. The exterior angle inequality theorem, T34 in our case, says that if an angle is an exterior angle of a triangle, then its measure is greater than the measure of either of its corresponding remote interior angles. Let's look at a picture of this. Here we have our triangle ABC. So our exterior angle we're going to use is this angle, and we'll call this angle D. So the remote interior angles corresponding with that exterior angle D would be angle A and angle B. Well, what this theorem is saying, if an angle is an exterior angle of a triangle, so we have that angle D as exterior, then its measure is greater than the measure of either of its corresponding remote interior angles. So, the measure of angle D is greater than the measure of angle A, and the measure of angle D is greater than the measure of angle B. And that's what this theorem is stating. In the next video, I'm going to teach you a new kind of proof, and that's the indirect proof. And we're going to use the indirect proof to prove the exterior angle inequality theorem.